Okay, so welcome to chapter 14. To begin this chapter, we're asking whether it's growth or decay, the first four problems. So I won't tell you the answers to these, but I'll just go ahead and tell you how you can determine whether it's growth or decay. So exponential equations are in this format: y equals a times b to the x power. And sometimes, or most times, b is in parentheses here. Now, a is always going to represent kind of a starting amount, okay? Whereas B represents usually the rate of whether it's growing or decaying. Now, if B is a number that's bigger than 1, let me make this arrow look a little bit better, but if B, that's just still worse, if B is a number that is bigger than 1, then it is growth. If B is a number that is less than 1, it is decay. So, in short, if I gave you, I won't do your examples, but I gave you, let's say 5, and then I had times 3 to the x power. So that makes 5 the a and 3 the b. And since 3 is obviously bigger than 1, this would be a growth problem, an exponential growth equation. If I had, 2/3, and then I had 5 to the x, remember, that's my a, the 2/3 is. 5 is my b, and again, since 5 is bigger than 1, this would also be growth again. So if I had 1/2 and then I had 2/3 to the x power, remember, 1/2 is a, 2/3 is b, and since 2/3 is smaller than 1, this would actually be decay. So it's just that simple. The a value that's up here basically is meaningless to determine growth or decay. It's useful for other things, but if you're just determining growth or decay, that is primarily and just solely based off of b, and the a value is completely irrelevant there. So that's enough information, I think, to answer 1 through 4. Okay, number 5 and 6, all these other ones. Growth decay models, evaluate, specified, describe the problems. So you've got the growth and decay formula, and that'll also be on the formula sheet. So of course, growth formula is, I'll just write y for this one. Y equals a 1 plus r. What does it say, to the t power? And then decay is, y equals a 1 minus r to the t power. So just remember, a is always your starting or initial amount. So, if I'm going to give you a different example based, not the same as the ones that are there, but let's say I invest $5,000, right? Or something, or I don't know. We'll just say, let's say my starting amount was $5,000, right? And my money is growing at a rate of, let's say, 4% growth. Okay. Well, if it's growth, then it's going to be this equation, so 1 plus. But it's not plus 4. That's the part people get wrong a lot. Whatever your percentage is, you have to move the decimal value. So if it's 4%, that's 4.0, right? Because 4.0 is the same as number 4. You'd have to move the decimal 2 places left, which makes it go here, which would be 0.04. So you would put in the problem here 0.04 if it told you it was 4% growth. It's very important that you remember to always move that decimal. Okay, and then to the t power for the exponent. Now t is for time, so if I want to find the value of this after 3 years, then I would plug 3 in there, and that would be it. Ooh, let me turn that off. And that would be it. You can type that in the calculator, get the value after 3 years, bada bing, bada boom, you're good to go. So pretty much all those problems are very easy to do as long as you use the correct formula. If it's growing, use this one. If it's decaying, use this one. Just remember percentages and converting them into decimals. So let me just practice that real quick. Let's say you have 80%. Well, 80%, this is 80.0, right? So the decimal needs to be moved 2 places left, just like always. So go here, which would make it 0.8 as a decimal, 0.8. You don't necessarily need the 00 part there, but or 0.80. Just 0.8 is the same thing, right? If you had, let's say, 1.3%, that decimal 1.3 has to be moved 2 places left, which would make it 0.013, 0.013. And a really tricky one is if you get something that's already sort of a decimal, like 0.4. Now 0.4%, it's very tempting because it says 0.4 and you're like, oh, that looks like a decimal to me. Well, you're not wrong. It is a decimal, but it's still a percentage. See, it still says a percent there. So you still have to move the decimal place 2 places left if it has that percentage there. So if you do that, it's now 0.004. So, oops, yeah, now I even wrote it wrong. So you still have to move the decimal place 2 places to the left every time you have a percentage value, okay? Whether it's a decimal or not, you still need to move it, okay? Yes. Now number 9 and 10, you have the formulas already given for you. Basically, it's just this chapter is basically just a plug in the formula kind of chapter. So the compound interest formula, the first one you see, which is A equals P0, and then 1 plus R over N, then N times T. This is for anything that's compounded, it could say annually, compounded annually. It could say compounded semi-annually. I'll explain what all these mean in a second. Could be compounded quarterly, or it could be compounded maybe monthly, okay, etc. So what these means is how many times it's computed in a year. So if it's compounded annually, it would be, let me put a different color here so it stands out. It would be once, oh man, that's not a different color, is it? Blue. It would be once a year. Where if it's compounded semi-annually, that would be twice a year. If it's compounded quarterly, that's 4 times a year because 4 quarters in a year. And if it's compounded monthly, that would be 12 times in a year. And that's the end value. The end value is how many times it's compounded. So if I have a problem, and I'll put these parameters out, not the same as yours, but if let's say I have $5,000. Let's say I'm investing at a rate of 3.2%. And let's say I do it for 10 years. And let's say it's quarterly. Okay. So basically, yada, yada, yada. I can't spell words. That doesn't look like a word, but it's okay. Yada, yada, yada. I'm investing $5,000 at a rate of 3.2% for 10 years, compounded quarterly. Then this is all the information I need to just plug it straight into this formula. So remember P0, the 0 is a little bit deceiving. You don't actually need that 0 for anything. This just means the starting value. So that number would be the 5,000. So it'd be 5,000 as that P0 thing. And then it'd have 1 plus R over N. So R is our rate, which remember is 3.2%. But just like we talked about, you have to move. Every time you see a percentage here, you move that decimal over. So it'd be 0.032 is what I would plug in. 0.032 over N. Now, N is very important because it's compounded quarterly. So that means 4 times a year. So that would have to be the 4 in the denominator there. So that's very important that you put that 4 there. Quarterly is where I'm getting that from because quarterly means 4 times a year. And then the exponent is N times T. So N is, again, 4. And then times T. T would be 10 years because you're doing this for 10 years. So it would be 4 times 10, which would have, of course, just end up making that 40. So it's very straightforward. It's just a formula. You've got the numbers. You plug it straight in. There's no math to be done here. You just take your calculator out and you plug that in your calculator. Now, if you're wondering how to type that in the calculator, let me show you. Okay. So remember this screen here. Okay. Take a picture of it or something if you need, because I can't show this in the calculator at the same time. But let me go back to my calculator. So if you're going to use your calculator, you can type in the 5,000, and then you can type the parentheses, and you do the 1 plus part. Now, here's a part that's really important. The fraction, right? That R over N. If you hit alpha, Y equals, and then enter, the first thing that shows up there is N over D. I haven't hit enter yet, but alpha, Y equals, you get this menu. If you hit enter here, you get a fraction. Now, you can type that fraction in a lot easier. What was it? 0.03. What did I say before it was? 0.032. So 0.032, and then divided by 4, because that was my quarterly, right? And then I can close that parenthesis off, so it looks good, right? And then I can raise that power. And I could type in 4 times 10 here if I wanted to, or I could just type it in as 40. Either would work as long as you, of course, have the correct numbers. So hit enter on it, and you get your answer. So that's what number 9 is. Oh, number 9, that's not number 9. Number 10 is that question. Number 9, look at the difference in number 9. Number 9 says compounded continuously. So Just keep in mind that this formula here, can I pick a color that stands out? What's a color that stands out? Pink. This formula here is used if it's compounded any of these times, any specific amount. But if it says compounded continuously, then you're always going to use the formula. That's the PERT one. Now they have P0 ERT, but P0 is the same thing as just P. But compounded continuously, this word is very important. This word is a completely different formula, but it means essentially the same thing. So if I had $5,000 to start with, and I was compounding at a rate of 3.2% for 10 years, compounded continuously rather than quarterly, then what I would do is I'd plug the 5,000 in for the P0, just like I did in the other problem. Now, E is E. It's part of the equation. It's something that's part of the formula. It's just what you type in the calculator, and I'll show you that as well. R, remember, is rate. Just like before, you have to make that percentage a decimal, so it'd still be 0.0 or 0.032, just like the last one, times T, which would be 10, right? So this is how you type it in. It's the same process, but a different formula, all right? Again, don't be confused by the 0 here. People might think that that means something. P0 is just means the starting amount, which is 5,000. 5,000 is essentially P0. So if you type this in the calculator, it would look like this, 5,000. And then here's the E part. So E is second, and then ln, the number next to 4. You can see the E above it. And then now you can type in the decimal times the time, the rate times the time. Just like that, and you would get an answer. Okay? So different formulas for different reasons. That first one that we showed would be used if it's compounded a specific number of times, like annually, once a year, semi-annually, twice a year, quarterly, 4 times, or monthly, 12 times. Whereas this formula is only going to be used if it's compounded continuously. That word continuously is the giveaway. It tells you that you're going to use this formula. Okay. As far as 11 and 12 go, graphing it, that's just straight up on the graphing calculator. So you could just go to your graphing calculator, go to y equals, plot your graph here. So, yours is 5, then 1/2 x. I mean, I guess I could show you that real quick. 5 and parentheses. Again, if you want to type the fraction, get some practice. Alpha y equals, you can type in that fraction as 1/2, which is nice. Just like that. You don't have to do it that way. There are other ways to do it, but that's the way I would prefer. And then to the x power, don't forget that very important step. Now you can graph it, but I think we need to fill out the table first. So if we look at the table, we could fill out the table. So this table here is the same table that you have. Am I in the right place here? Hold on. That's what it looks like. Can I go to this table? It's not letting me scroll up for whatever reason, which is really, really odd to me. Can I start at -2? Okay, yeah, it's not letting me scroll up. Okay, it is now, but it wasn't a second ago. But anyway, there's your table values. You can just plug them in, and then, of course, plot them on your graph, and you're all set. So number 12, same thing. Just graph it, go to the table, plot the table, plot those points on the graph. You're all set. That's chapter 14, folks. I'll see you in the next chapter for chapter 15.